Okay, so we're going to look at some of the beginning parts for the unit circle. So we start with a circle, which can be anything that you have, generally on paper, or what I do is I take a very cheap paper plate, and where the line is, I cut it so that I have a circle. You can trace a lid, anything that you want, so that you can have a circle that is ideally cut out, so that you can fold it in half so we can get our axes. Okay, so fold it in half, draw your axes in there. I'm going to use my pen, theoretically. Okay, so that's one axis, and then fold it in half again. I find if you use a paper plate, you can't do more than like 2 layers, 2 folds, and then it doesn't fold so well. Now I'm going to fold it a bunch of different ways just so that I can get my axes drawn in there. I find drawing on folds works pretty well. All right, so then we're going to label our X and our Y. A lot of these we can put on paper afterwards and label things with that. So we're thinking about what we know about a circle. A circle is 360 degrees. We're always going to start with the positive x-axis. That's going to be our 0. So I can start with, this is my 0 degrees. If I go all the way around, I'm going to have 360 degrees. If I only go halfway around, I'm going to have 180 degrees. Okay. And if I go half of that, this will be 90 degrees. Now, the degrees I like to put towards the center of the circle. Sometimes I go even closer in, but for right now, this is going to think this isn't necessarily going to be my final unit type circle. We're only going to put the 45 degree angles in here. And then we're going to do another one for our other special right triangles, but that'll be a separate video. So this is 270 degrees just because everything is 90 degrees in there. Now, the other thing that we're going to think about with this, before we do too much more, is we're going to think of like coordinates and of where things are. So this eventually will become on thinking the XY plane, the Cartesian coordinates. So the center here, this is going to be the point 0, 0. It's going to be the origin. And then we're going to put other coordinates along the edge. With circles, all circles are congruent or similar to each other, not congruent. Meaning I can just change the side of it and they're all going to be in proportion the same thing that we have. So mathematically, we like to think of what is the easiest thing to work with, because we don't really want to do a lot of extra work, because we want to think of different things. So the easiest number to work with is 1. It does all kinds of special properties. Multiplying by 1 doesn't change anything. It's a nice, easy number to multiply by, nice, easy number to divide by. So in general, we're going to pick this to be a circle with a unit circle, so a radius of 1. That'll come in as we start looking at some other stuff. So we've got some of our basic information, just the axes, and we know that those are, you know, the 90-degree quadrantal angles. And then what I'm going to do, remember, if I'm thinking about this, I want other special right triangles, or special angles that we have. So if I really think about this, the first easiest special right triangle that we've talked about is the 45, 45, 90. So if I could divide each one of these quadrants in half, I will be able to see my 45 degree angles. And for that, I'm just going to fold up on each side. If you have really thin paper, you can just fold it in half and then half again. But I find my paper is a little too heavy, so single folds is enough. Okay, so we've got those in there. And now I'm gonna redraw those in just because I like to see what I have. So I'm gonna fold again. This time I'm gonna use my pencil to draw my lines. Okay. Now, I do recommend making one of these yourself. It helps, the more senses you get involved with something, the easier you can picture it later on. At least that's what I find. Now, with this, that we have every quadrant is now divided into 4 more spots. Remember, our quadrants are 1, 2, 3, and 4, and thinking of your positives and negatives with that. But this is going to be my 45 degrees. Actually, I'm going to put these at the very center. So this is my 45 degrees. And then if I go all the way over to here, because we're going to always start with a positive x, going over to here, this is 135. And then we keep going into here. This is 215. No. 225. Sorry. I can add and think of numbers in my head sometimes. So 225 degrees. Sorry. And then this is going to be my 315. So those are my 45-degree angles. If I think in degrees, a lot of times we think of turns as in degrees where we're thinking about. Now, circles have 2 parts. We have the inside stuff, and then we also have the outside, which we usually call the circumference. With dealing with the circumference, the way that I like to think about this, we also have the radians. Now, radians are an arc length, which is just a part of the circumference. So if I think about this circle, and remember, I determined my radius of this circle is going to be 1. So if I go all the way out to here, it will be the point 0 or 1 0. If I go up to here, it'll be 0 1, and this will be -1 0, and then down at the very bottom would be 0 -1. We are going to label that, but I think I'm going to do that when I put it down on paper. Right now I'm going to be moving it around, so I'm not going to put that up there yet. So we have a radius of 1. Circumference is pi times diameter. So if my radius is 1, that means my diameter is 2, and the whole circumference is going to be 2 pi. So one of the other things that I like to mark on this is thinking about what the radians are. So degrees and radians are just 2 ways of measuring a turn within a circle or an angle. So I do know that this is also 0 radians. If I get my pen working. Okay, so I have 0 radians. And if I go all the way around, it will be 2 pi is the whole length because my radius is 1. So I can think of this as 2 pi radians. Then if I think about this, we're going to think fractions. And fractions, remember, is how many sections we can break things into. If I only go halfway around the circle, this is going to be pi radians. Okay, and this gives us a great a ratio of a comparison that we have, because we have 180 degrees and we also have pi, so they're in the same location, they do the same turn, so we can always use that comparison of 180 degrees equals pi radians. It's about as clean of a ratio that we can do, so we'll use that when we're converting between angle degrees and radians, or radians and degrees. All right, so thinking about this, breaking this back into where we had it, so thinking fractions, if I only go halfway around instead of being to pi, this is going to be pi over 2. And then if I'm counting, looking at the quadrants, I've got 1 pi over 2, so 1 pi over 2, 2 pi over 2, which is just 1, and then this one down here will be 3 pi over 2. Okay, so thinking about this and working at how we're labeling things, we have our 45-degree angle. We're going to think about that in a second, but I really want to focus on the better unit or small unit of just pi. Pi is 1 pi. And when I'm thinking of fractions, remember the denominator is always how many pieces we've made it into. So if I take this pi and I've divided it into 4 pieces, each one is worth pi divided by 4, or 1 pi over 4. So this 45-degree angle is going to be pi over 4. I'm going to put it out here. And then if I keep counting around, so this is pi over 4, 2 pi over 4, which is already labeled pi over 2 because I can reduce it. This will be 3 pi over 4. 4 pi over 4, which is pi. And then keep going around for the rest of the circle. This is going to be 5 pi over 4. I should put that below it. I think I'll move it later. 6 pi over 4, which is 3 pi over 2, reduced. 7 pi over 4. And then I'm up to 8 pi over 4, which is 2 pi. So labeling in radians, it's just 4 sections. They're pi over 4s. That'll make life a little bit easier when we start thinking of reference angles and stuff like that. Reference angles are just getting back to a simple thing and then worrying about the signs of things afterwards, so positives and negatives. Now, we can always... What we've worked with before are right triangles. So we're really going to be thinking of, a lot of people will do a unit circle and just memorize all the stuff on the outside. I don't find that useful because to use any of the information, I'd have to draw the whole unit circle, which takes a couple minutes. And then I don't have really workable stuff. I just have this reference that I've memorized and don't understand how it works. So really what's the whole purpose of a unit circle is to think about the triangles that we have, and specifically right triangles, because we have the Pythagorean theorem, which works for right triangles and tells you that the square of each of the legs added together will equal the square of the hypotenuse. So it gives us a great way to find the lengths of things, and when we're dealing with trig, we're looking at ratios of sides and angles of right triangles for the most part, and then we have ways to deal with non-right triangles that we'll deal with later. So I'm going to focus on the first quadrant, that 45-degree angle, and then we're going to be adding in the right triangle of things because we're going to be thinking of coordinates. And I'm going to try to keep my paper evenly on my paper plate, and going with that. Okay, so what we're going to do is we're going to hold this as tightly as we can, and we're going to start putting our coordinates in here. Remember, I told you that on my positive x-axis, I have the coordinates 1, 0. And up at the top, I have the coordinate 0, 1. And then off to the left, I will have negative 1, 0, so the negative x-axis. And then the negative y-axis, we will have 0, negative 1. Okay, and that's a little off my picture, but we'll focus on the top, and then I'll slide it up. Now, we do also know that I can draw... From a point, points are x and y's, and if I'm thinking about it, I have my x distance, which goes across over, and my y distance that goes up. We said that the radius of this circle is going to be 1, so I'm going to label that radius of 1. And now, remember what we have with a 45, 45, 90 triangle. This is my x. This is my y. Using Pythagorean theorem, which I could put on the back of my circle, I have Pythagorean theorem, which is a squared plus b squared. B squared equals c squared. If we're talking on the coordinate grid, I have x squared plus y squared equals r squared, because that's how I've labeled this right triangle that I have. I have x, y, and r is my hypotenuse because going to straight down. And then because I have a 45, 45, 90 triangle, I can know that the x and y have to equal each other. So I'm going to change this to n squared plus n squared equals r squared. Doing my algebra, combining like terms, so this is 2n squared equals r is 1, and 1 squared is 1. All right, dividing to get my n by itself, so divided by 2. So you have n squared equals 1/2. Then you get to square root both sides. And square root both sides, and remember when I'm square rooting a fraction, it's square rooting top and bottom, so I have n equals 1 over the square root of 2. Rationalizing the denominator just because it's good practice. It's not always required anymore, but it is good practice. This will give me n equals the square root of 2. And the square root of 2 times the square root of 2 is the square root of 4, which is just the 2. Remember, pluses or minuses. However, we're talking distances, so in this case, it is going to be positive. When we move it around the coordinates, it'll change based on location. All right. So I know that this is the square root of 2 over 2, and this is also the square root of 2 over 2. Okay, so this point right up here at the end of my 45, 45, 90, or my pi over 4 radians is going to be the coordinates square root of 2 over 2, square root of 2 over 2. All right, now the the 45 degree angle in quadrant 2, so the 135 degree angle, is also going to be, I'm going to make this go like this. Our angles always go counterclockwise, starting from the positive x. It's still going to have the same sides of the triangle when I'm looking at that. However, it's in quadrant 2, so the x is going to be negative. So this coordinates are going to be negative square root of 2 over 2, and the y is still going to be positive. Okay, so I'm really thinking of, I have a 45 degree angle, going with that and figuring out what quadrant I'm in based on where that triangle would end up with. And then all I'm doing is, I know it's a 45, 45, 90 or pi over 4 radians. I know my sides have to be the same. They're going to be square root of 2 over 2. And then I'm just worried about whether or not they're positive or negative. So then if I go scooch up and then go to quadrant 3, in this case, both coordinates are going to be negative. So negative square root of 2 over 2, negative square root of 2 over 2. I have my 0, negative 1. And then quadrant 4, going to be the same thing, only this time my y is negative, my x is positive. And this is square root of 2 over 2, square root of 2 over 2. Now, you can put a whole bunch of other stuff in there. I tend to separate my two sample special right triangles just because it gets a little messy looking at this. But this is the start of my unit circle with my pi over 4 or 45 degree angles and my special right triangles of the isosceles right triangles. And working with this, I don't memorize the outside thing. I really am picturing my triangles going in there. So I do recommend making this yourself, visualizing that triangle, thinking of that triangle in a constant thing. It does take time. It does take practice, but it's all doable. All right. So next video will be the 30, 60, 90s.